Welcome Linux enthusiast. This is the 13th episode of our Linux learning series. If you have missed any of our previous episodes, then click on the playlist above. In this video, we'll be covering the various system administration tasks available in the Linux machine. If you are looking to upskill in Linux and get globally recognized certificates, then I suggest to check out our DevOps course. Here is the link below in the description box. Alright, so let's start the video now. Alright, so we'll be talking about system administration in these slides, and we see that what is system. When we talk about system, which means our Linux machine, and how do you manage the Linux machine storage, partitions and devices. So those are the things which comes under the administration part, and we'll be talking about what is a disk and what is a partition in this. So as you may all have seen in Windows, C drive, D drive, E drive, so those are nothing but the partitions of your hard drive. So let's say there is one hard drive which is of 500 GB, and then you have seen so far there are multiple sub drives that you can create, for example C, D and E drives. So if you look at in this image of PPT, it is describing about the partitioning and the file systems in Linux. If somebody asks you how many partitions you can create in Linux, so the answer is 4. Okay, but you must be thinking, how can it be 4? I have seen multiple more than 4 partitions, then why is it not more than 4? So overall partitions in Linux can be maximum of 4, but now there is a trick is what kind of a partition it is. So if we talk about that in detail, so in Linux we can create 4 primary partitions. So let's say this is your hard drive, okay, and in the hard drive you create partitions, okay. If you are having primary partitions, so you can have 4 primary partitions, okay. This is one way of doing it. Or you can have let's say 1 primary partition and 3 extended partition, which represents by E, okay. So why I said 4 is because maximum of 4 partition it can create, but under the hood if we talk about in the extended partitions, so in the extended partitions we can see that you can create multiple more partitions. You can create more partitions like logical partitions you can create, which are called LVMs. We'll be creating shortly in this demo session. So in the extended partition you can create multiple partitions. That's the reason you can always have multiple partitions and create more than 4, but overall if somebody asks you, then a partition can be 4, maximum is partition 4. So if you create 4 primary partition, let's say for example if we talk about in the Linux machine, let's say if you have a drive of 500 GB, okay, in that 500 GB of drive, if you create 4 partition of 100 GB, 4 primary partition, let's say if you create 4 primary partition 100 GB, then 100 GB will no longer be used anytime later in the future, which means it will be left out like this. So the reason being, we chose to create primary partition. So if you create primary partition, then all these 400 GB will be used, but not the remaining 100 GB. So it's always suggestible that whenever you create a partitions in your hard drive in Linux machine, you should always create 3 primary partitions, okay, and then 1 extended partition. Extended partition means you can further extend those partitions. That's why they are being called extended partition. You can further create more partitions to it, and that's how you can create extended partitions. So that is about how do you basically create the partition. So when we look in the partition table, so the first 2048 sectors of your partition table, that is being always be blocked for certain use cases, like where it stores the inode numbers, it stores the metadata of your files. And now in the modern environment, there are modern partitioning systems and stuff which supports that 4 KB partitioning metadata kind of a stuff, which always requires that amount of sectors, the initial sectors of your partition to be left out. So in this example, you are seeing a hard drive of 10 GB, and there is 2048 sectors. We'll be talking about what sectors is. It's kind of, you can you can think like, the minimum value parameter to measure any hard drives in the form of sectors. So it's like, you have a hard drive. uh, let's say for example you have a hard drive, and then hard drive is like this. So it starts from, let's say, sector number 0, then it goes to, let's say, 1000, then 2000, and then let's say for so and so stuff. But this sector from 0 to 1000 contains certain MB of data. And how much is it? So number of so if you want to calculate the size of it, so you have to do sector multiply then one sector size, which is 500 MB, 512. So if you multiply this, then you will get 500K. So this much size of 0 to 1000 sectors are being defined. So that is, there is a formula to calculate the size. So it's always be calculated in the form of sectors. That's how Linux file system partitioning understands. So the initial 2048, you see this, it is reserved for the metadata and inode numbers. Then remaining, there are 3 primary partitions created, 1 GB, and the remaining, the last one, extended partition created, which is of 7 GB. So in that further 7 GB, there are you see, you can maximum up to 60 partitions can create inside extended partitions. You can create further more. So in total, if we calculate, so 63 partitions we can create in the hard disk. So, and we will be talking about the commands which are required to see the partition table, which are required for mounting a partition, and how to create a partition, what kind of a partition. If you want to format a partition, how do you do that? What kind of a formatting mechanisms are available to format the partition? So we will see all these things in the hands-on part. So there are a few commands. Basically, it is talking about how to partitioning the disk. You can see there is a command called fdisk command, basically, which is used to discuss about the partitioning tables and all. So let's go the demo thing, and we will see how does it look. So for this demo, in my parallel desktop, what I have done is to this client machine, I have created one more hard disk so that I can show the demo for logical partitions and stuff. So there is one hard disk which is of 64 GB already allotted. There is one more I have created just for the demo, so that we will be seeing the partition here, which is of 5 GB. Okay, so now that 5 GB is nothing but SDB1. So if you remember, we discussed in the file hierarchy systems where all the device type files are mostly being stored under /dev. So similarly, like this, if you look at this, so SDB is also a block type file, which is a device file. It's a block, which means it's a sectors, hard disk and something. So SDB is what we created for 5 GB, and SDA is 64 GB is by default created while booting up this machine. So we will be testing out on the SDB and see stuff. So the command to check the partition table is df command. So you want to see the file system, so df is just to describe or display the file system for you. So let's understand what it is actually trying to tell. So this is the file system that is currently available on my machine. This is the size of that file system. Each and every size you can see. SDA 262 GB out of 64 GB. SDA1 is 1.1 GB. So if you calculate, it's roughly around 64 GB. Then SDB1, which is there, I have created is 435 MB, and there is one more logical partition being created of 1 GB. Okay, and this much is used percentage. This much is used size of the partition. Then this much is available partition. This is an MB. K stands for KB, and G stands for gigabytes. Then percentages of use case, how much is used. You can see the percentage here in the file system, and the mounted, where it is mounted. So when I say mounted, what does it mean by that? Mounted means you are making the partition accessible. So how do you make it accessible? You mount it on some of the directories. If you don't mount it, the partition will no longer be used. It's unable to actually access it. So what does it actually? So if you remember, when you in the day-to-day basis, when you try to connect your USB drive or pen drive, right, in your system, you see there is another folder of USB automatically being created. So that folder is nothing but mounting. So it has mounted successfully on your file system, and that's why you are able to access the entire partition size or entire size of your pen drive and external hard drives. So that's how mounting is very much required. Without mounting, you will not be able to access the partition. So currently, if you notice, for SDB partition, which is of 5 GB, we are only using 1.5 GB of it. So this 5 GB I am talking about, we are only using 500 MB in the first partition layer, and then another in the logical volumes, that 1 GB, but the remaining 3.5 GB is still left out, but it's not showing up in the partition table. Reason being, it is either not formatted or not been used or not been mounted yet. So that is the reason you are seeing that left out and not being used, and it does not show up also in the partition. uh, and if you look at like this lsblk command shows you a little more detail about in the tree structure. So if you look at this SDB, which is of 5 GB, but currently we are using these two partitions, SDB1 and SDB2. One is of this much and SDB2 is of 4.5 GB. But from this 4.5 GB, we are only using as a logical volume of 1 GB. So that is the reason you are unable to see this remaining 3.5 GB, because it is not been used. It is there, but you can create more logical volumes out of it, but you will not be able to see it until you mount it. So lsblk command, you can note, this command will show you in detail the tree structure format of major number and minor number, and size and read only partitions or something. So, and mounted on which folder it is mounted. So that's what it is telling. So that is the df command actually. If you want to see df home, so it will show you that this home directory where all the users home directory is present. So this is basically coming from original file system, which is SDA2, and 1K block, it is this much block and this much is it's used. If you want it to be human readable format, better to add option -h. -h basically gives you human readable format, so you can see and read more easily. Out of 62 GB, used is 8.7 and then available is 50 GB. So currently it is using 15% of your file system. Okay, right. Now how do you measure the directory file storage? Disk file df command will show you. Directory usage you can use with the help of du command. So du-sh, let's say I want to see this home directory, this directory home parallels, how much storage it uses, which is 129 MB. So du command will help you to display the disk usage here, and df command will help you to display the file system usage there. Okay. Then there is a command called mount command, which only works with sudo. So for example, if you want to mount any partition, so let's say there is a partition called STB3. Suppose there is a partition and you want to mount it to a directory. So I want to mount it to /mnt. I can mount it like this. Currently this partition is not created. That's the reason it's saying that does not exist. If it would have exist, then it would directly be mounted to me /mnt directory. Okay, so /mnt is nothing but a directory here. So /mnt, if you look at the dot present directory, it's a directory type file. Okay, so that's how it is basically showing up the mount. Okay. Now there are two directories you see inside /mnt where we have mounted some of our partition. For example, in df-h, if you look at /mnt primary partition is a folder which is what is storing this, and /mnt my disk is storing this logical volume. Okay, so that is how you can see. And then similarly, sudo umount, you can unmount any of your disk if you want to unmount it. So let's say if I'm unmounting, sudo this mnt my disk, and I execute, and then I see df-h, I no longer see this mounting file system. Okay, so mount -a command, what it does is it basically mounts, remount it, whatever the mounting configurations are being written. There is a file called etcfs tab. It's very important file, you should make a note of it, that this file is very important. Whenever our Linux system boot up, it reads this file, and this file tells about the listage of the partition that you would want to mount, and where do you want to mount, and what file format you would want to mount. So this was the label for lbm, and this was mounting on this mnt my disk, which is unmounted earlier when I executed umount command. But after mount -a remount, this command reads this file. So whatever the entries will be present inside etcfs tab, it will automatically mount those directories of file systems. Okay, so that is the mount command. What if you want to scan the file system? So you can run fsck and then file system, let's say sdb1. I will not execute it because if you scan the file system, it basically tries to checks the metadatas and stuff, so which is not recommended until you. So there are proper steps when we will be creating the partitions. That time we'll be discussing when to use this command, because this will check the partition and will make sure the sectors are properly appropriate and metadata is stored in the properly manner. So it's always recommendable to unmount the partition first, and then whenever you shrink or increase the partition size, that time you have to do this fsck. And if you want to forcefully do this fsck, there is an option called -y, which will force check your partition table. So that is how you can use fsck command. So far we discussed about df command, which will be useful for the partition table file system checks. File system, if you want to see the more information. Du command is for the directory usage. Then mount command is to mount the file system on a directory or device, whatever you want to mount on. And umount command to unmount the file system, the partition that you have created. If you want to unmount it from your file system, then you can execute umount command. And to repair the file system, fsck command is the important command, which basically repairs, or it basically checks the file system, it scans the file system, and if there are any bad sectors, it tries to check and recover those and correct those as well. So that's how it uses. Now let's talk about partition, and let's do some hands-on sessions as well. So lsblk command we have already shown up, where it will list out all the partitions to you in the proper tree structure manner. Now let's see if you try to create a disk. So let's say if I say this fdisk command. So fdisk command you are trying to create. So it's a welcome to fdisk. So it's currently in use. Repartitioning is probably bad idea. So it's already indicating to you, saying that this partition is already being used. Okay, so please do not touch it, otherwise there might be some issues or something can happen. So let's do one thing. We will do this, that we will switch off this machine, and then we will add one more partition so that we can play around with it, not to touch this partition. So I'll just say shut down. Okay, so this changes you can only do if your machine is in shutdown mode. So let me add one more hard drive, and let's create a new image, and let's see 3 GB we are adding up. Okay, and then say okay. So there is one more disk of 3 GB created, and now let's start our machine. See how quickly the machine reboots, the Linux machine reboots, and you can see That's where the configurations, it's telling what all services it is reading from reload configurations or enable configurations, and then FS tab and so stuff. So our system is booted. Let's log in. Okay, let's zoom it a bit. Right. Okay, so now let's see LSBLK. So now you see this SDC is already created and showing up in my table, partition table, right? So which is not being currently used. It's free to use. Okay, so it's 3 GB. So now let's try to do fdisk/dev/sdc. Okay, we have to use this via sudo. Now if you see, there is no more warnings has shown up now. The reason being, this partition was never being used. It was not mounted to any of the file systems. That's the reason it is not showing you any type of warnings. Otherwise, it shows the warning saying that please don't touch this partition. Otherwise, the data, whatever you have put up into this storage, there are chances that it could corrupt. So that's why you should always avoid, do the proper method, do the proper following, whatever is required in order to unmount the partition and then recreate the partition or shrink the partition or extend the partition. Since there is no warnings coming up, we are good to go. So let's try to see what helps we can see. It tells. So there are a lot of commands that we can execute. Delete a partition, add a new partition, and print the partition table. Let's say pre. When I say P, which means it is printing the partition table for me, 3 GB. See, here is a unit of the partition that I was talking about, the sector of 1. So one sector is always be 512 bytes. So you should always remember this. If you calculate the total number of sectors, so you can just calculate based on the size and divide by 512. To this, you will get the number of sectors which are available in this 3 GB of hard drives. So that's how you should calculate it. Okay, now so there is no more further partitions created. We are good to proceed with creating a new partition. So now it's asking you to create which type of partition you want to create. You want to create a primary partition or extended partition. See, I'll tell you this, you should always have a primary partition. If you directly try to create an extended partition where you don't have any primary partition, there are chances that it will not allow you to do that. So you should always have 3 primary partition, and after that you can have extended partition, or you can have at least 1 primary and then 3 extended partitions. So, but it's recommended ways having 3 primary partitions and then have 1 extended partitions. Otherwise, like based on the use cases, you can create take the references and create. So we will be creating the primary partition here. So that's why I'm pressing P. So primary partition, what is the partition number you want to give? Let's say I want to give 1, default 1. Here is the thing. So default, it is taking sectors from 2048 only. Why is it not choosing the sector from 0? As we already seen in the PPT, 2048 sectors are required in order to make sure the file metadata and inode numbers are being saved. So this is used to align the 4K sector devices. So there are some devices which are aligned to 4KB sectors, and that's what this 2048 is being used. And being always blocked, you cannot touch that initial 2048 sectors. Also, it is good to have a compatibility with the bootloader of your machine. Bootloader means a loader which basically loads the OS. So without bootloader, the OS cannot be loaded, right? For example, Grub is one of it, Grub 2 is another one of it. So those are the bootloaders which basically loads the OS. So to make a compatibility with the bootloaders, it has to have this 2048 sectors to be required. After that, these are the sectors reserved for the metadata and inode numbers that we have already discussed. And so it's always good to have left out this much partition for increasing the performance and the optimization in terms of performance of your OS or of your disk, whatever you are going to create. So I'll say default is 2048. It starts taking sector from 2048 and then create it. So you can either give the sector number or you can give like the size. You are seeing KB, MB, GB, terabyte, petabytes and stuff. So let's say I would want to say 500 MB. Okay, it's not taking, no worries. So let's say 500, let's say 1 GB. Okay, it's out of range, value out of range. We will be, say, okay. So now you have to create by adding this plus, reason being, this is like how much adding you are doing on top of 2048. So it will automatically create the number of sectors for you, and then it will allocate those sectors, how much the partition size you would want. So you should always have plus 500. So which means that on top of 2048 sectors, allot the sectors, number of sectors which will be coming up in the 500 MB. So, and minus would be to reduce that. So plus is to just to allot more sizes. So we have created one partition which is of 500 MB, and it is showing up to you. If you say P, it will print the table. Okay, so now you have /dev/SDC1. So this is one partition that you have created from SDC drive. Okay. Okay, so it says that it is automatically calculate the number of sectors it is going to end. So inside 512 MB, this much sectors is required, and that's how the partition is being partitioned like this. And if you want to save it, you can just press W, and then it will save it for you. And one more thing is this ID and type is Linux because we have created a primary partition. That's why it is, showing this ID. So now let's run this command lsblk. So it says from the SDC, which is 3 GB, we have created a partition SDC1, which is of 500 MB. Okay, so this is the partition that we have created. So for the disk, you will always see here the disk. Okay, for the partition, you will always see this partition part, which represents the partition. And currently we have not mounted this partition. That's why you are not seeing anything in the mount points. But if you look at this one, you are seeing the mount point, right? But for this one, there is no mount point. Now we are going to format the partition and then mount the partition to a respective file systems. So how do you do that? So let's try to execute this. Let's do one more thing. Let's refresh the kernel table, partition table. So there is a command called part probe, which basically refresh the kernel partition table for you. So this will update whatever the changes that we have done so far. We have created a partition called SDC1, and that we are going to update in that kernel partition table. Now let's use this command for creating partitions. So there are few commands people use it. Parted command is one of it, which is basically used for the GPT types partition tables, which is kind of larger disks if you want to create in petabytes and zettabytes. So those are recommended to create parted command. You can use that. Also in this thing we will be using MKFS. So let's see MKFS. I'll be formatting this using mkfs.ext4. ext4 is the format type. For Windows OS, if you look at the formats type, the format type is either FAT32, FAT64 or NTFS. So any pen drive which is formatted with NTFS or FAT32 or FAT62 will not be detectable in the Mac, because Mac OS or Linux OS does not understand that partition formatting. So if it does not understand the partition formatting, it will not allow you to access that hard drive, or you will not be able to access the content inside it. So sometimes you might have seen issues where you are connecting the pen drive which is formatted in the Windows format systems, let's say NTFS, and you're trying to connect to the Ubuntu system, which is a Linux based OS. So their formatting structure is totally different. So what is the best solution? Either you should use a Windows machine to detect their pen drive, or you should format that pen drive. So, but if you format the pen drive, the data will be gone. So that's how it is. That's how the Linux understands the file system. So it has to be compatible to that format in order to understand. Or you can look for some other tools which supports that file system to be formatted on the Linux machine. Then you can go for as a solution to this. So now let's format this /dev SDC1. Okay. So now it says that mke2fs. Okay, this is the mkfs command. It's allotted this UUID, which is a unique identifier. Super blocks backup, it has taken the backup of your super blocks. This much is required, whatever the backup was there, and then it is basically writing the super blocks and file system. So basically kernel is doing its own job in order to format the file system. There is a way to format it. It's kind of a very huge topic to discuss about, like how does this formatting work, what is a super block, and how do you store the backups. So that is kind of a detailed sessions, but in this we will be seeing that at least how does this partitioning happens, how do we format it actually. So it is taking the step by step, allotted the identifier IDs and super blocks and backups and so stuff. So those are the things, when you format the file system, it stores it. What if you want to format it? Let's say mkfs ntfs is one of formatting type to format it by ntfs, or xfs is another format, or ext2, ext3, which are the older formatting systems. So the differences between, if we talk about, right, so between each of the formatting style is different, because some of the styles has more inode numbers and more way, and more directories you can create and stuff. So their limitations are keep on increasing, their limits are keep on increasing with the formatting styles. So with the ext2 has limited inode numbers lesser than ext4 and xfs. So xfs is like far better than ext2, ext3 and ext4. So, and then yeah, so that's how the formatting types are being used, and that's how they format the disk. So for FAT32 you can use mkfs.vfat, so which will be formatting your disk into a FAT32 type, you know STC1. Let's say if I try this, it says permission denied. Let's use this. Okay, currently I formatted is with this. Okay, so you can format any, since we have not yet mounted, so you can format any way you want to format. So mkfs, let's say if I format xfs /dev/sdc1 sudo, then it will format this way. It says appear to be existing file system vfat. Use this option to override. So you can use option, since it is already formatted with vfat, so you have to use this option to format it with xfs. So once we do this, it's basically formatting it the way it should supposed to format. So every formatting style has its own mechanisms under the hood which it used to format the device. So once you format the device, you can label the device also if you want to. E2 label is the command. Let's say let's label it with let's say StarAgile, StarAgile, to label the device STC1 StarAgile. Bad magic number to STC1 contains XFS file. There might be some problems with the file because we have formatted with the different ways. Let's okay, 64 again. Let's see if it does format. Okay, now it has labeled the device. After labeling, you can just mount it to a directory. So I'll create a directory /mnt StarAgile. Okay, sudo. Okay, now let's mount it. Mount /dev stc1 /mnt StarAgile. Okay, now let's check our partition. So currently it says that SDC1 is mounted successfully on file system called MNT StarAgile. Let's try to check the disk usage of that MNT StarAgile. So let's use this du command. So this du will tell you that this much usage it is doing currently, and if you say fdisk-l, it will tell you all the listed file systems. SDC1 500 MB, and it is formatted this way, and df-h it says that the partition that you have just now created, it's 1% in use currently, and it is successfully mounted on the MNT StarAgile. Okay, now let's unmount it. Umount. So either you can unmount like this /dev/sdc1. Okay, or you can unmount with the directory name also. So either with the file system name or with the device name. So anyways you can unmount the partition. Now if you say df-h, this will no longer be shown in the file system because we have unmounted it. Unmounted means we have kind of ejected the pen drive. Usually what is what it says about unmounting. You are just removing from the mounted partition, so it no longer being showing to you. All right, now let's try to add the entry in the FS tab so that we will be using FS tab in order to make the changes. etc FS tab. Okay, let's say label, we will do the same entry. Let's copy this and then paste it. We have labeled our partition with StarAgile. So you can either use UUID if you have it. Okay, if you don't have it, then you can use label. So UUID, you can see there is a command called buildkit command. We will show that in a bit. But since we remember that we did label our partition, so we will be saying look for the partition which is labeled as StarAgile and mount that partition onto /mnt/StarAgile. Okay, the partition formatted is ext4, and after that it says that what kind of format types you would want to choose. So there are multiple mounting options. So currently it says default. There could be read only, read write and stuff. You can choose to do that. Sometimes some for input output operations you set up to async, and there are a lot many others are there. And then this 0 represents the dump field, which means that you want to dump or take the backup of your data if you would want to. So if you select 0, which means it will skip the backup, it will not take the backup for this partition. And this 2 is the fsck order, which means that it basically defines the priority of your file system. So if 0, which means no checking, if there is set to 2, which means checked after the root, and 1 means it's set as a high priority. So for example, if you look at this boot partition, so the priority for this is 1, which means it sets on the first priority. So this partition should be booted first, and then these partitions should be booted. So that's how the priority you can assign. So let's, how do you reload this file? The command called mount-a, sudo mount-a. So it says that your FS tab has been modified, but systemd still uses the older version. So you can use this command to reload it. Okay, let's reload this daemon. Now let's see it. df-h, it will showing you that whatever the entry that we have done in the FS tab. Now let's add the entry via UUID, not via the label. So okay, there is a command called buildkit to identify the unique identifier of your drive. So this is the unique identifier. Okay, block size, type, and etc. So those things you can check here. So what if you want to, so just copy this from here. Okay, let's unmount /mnt StarAgile. Okay, now we will go to FS tab. Now instead of this, we will say like this. Okay, StarAgile 64. and let's comment this line. So once we comment this line will no longer being used, and whatever the uncommented lines are there, it'll be using those to mount it. So let's say sudo mount on mount a. After that daemon reload. See, okay, it has not read it properly, maybe some issues. Cannot find this UUID. So let's try to check UUID StarAgile external default 02. /SDC1 label is this, UUID is this, copy, okay. Last time it was not, I guess, updated because it was not showing the label thing and stuff, but now this time it is updated. So let's try to mount again -a. Yeah, now it should supposed to see. Yeah, so that's how you can mount it based on your UUID or your labels, or you can directly give your partition name /dev/sdc1, and then after that you can just give where you would want to mount it, what file system, which priority you would want to put it on, 0, 1 or 2, and do you want backup or not. So you can change those things accordingly. So that is there. After that we will be seeing how to resize the partition. See, resizing is good to know, but it's just that when you shrink the partition, that's very important. There are chances sometimes when you shrink the partition, it can reduce the partition though, but there are chances for the data loss. So it's always recommendable that either you don't shrink the partition, which if I talk about the industry perspective, there is never be a requirement usually to shrink the partition. It's always a requirement to add on the partition, to extend the partition, but not to shrink the partition. But for example, let's say if in case you have to shrink the partition, make sure the partition backup is there, so that if in case some sectors goes into the bad state or file system gets corrupted, you can recover it, you can copy at least the data back, whatever the backup that you have taken. So if you come across these scenarios, then always preferable that you take the backup of your file system that you are going to do. So let's talk about shrink. So there are respective commands and stuff to do that. It's not it's fine to, if you don't remember the exact steps, you can always Google up and then get the commands, whatever the step by step it's required. So we'll be talking about that. Okay, so first of all, to shrink it, let's say you have to scan the file system, fsck. You can run, there is a command called e2fsck -s. Forcefully I'm scanning the file system check. Okay, so this is what it say it is mounted, cannot continue, so you have to unmount it first. So let's say sudo unmount. Okay, now it is not mounted. Now we can run this command. So this is basically checking the inodes. Okay, the first check is pass, checking inode blocks and size, then directory structures, then directory connectivities, and so all these 5 checks are successfully done, which means our file systems is perfectly fine so far, and we are able to scan it. It's properly scanning as well. Now let's resize this partition. So there is a command called resize to fs, and then we want to resize STC1. So earlier we gave 500 MB, let's resize this to 100 MB. Okay, let's resize it. So now it says 100 MB. Okay, M is there. Yeah, So resizing file system on this, okay, reduced it. Now the file system is this. Once we resize the files, the file system, we have to reduce the partition now. So see, the thing is, first the partition was created in 500 MB. After that, on that 500 MB, the file system was mounted, which means the file system was scattered across that 500 MB. So initial thing is check your file system, scan your file system. Once you're done with the scanning, reduce the file system, because without reducing the file system, you cannot reduce the partition. Otherwise, what will happen is there are some data which is there in the, let's say, another corner of your hard disk or your partition, but you have not reduced the partition file system, then the partition reducing might lose the data for sure. So it's always recommended that, see, think like this, right? So there is a room. In that room there are sofas and chairs and stuff, right? So if you want to half the room, what do? You first shift your sofa and chairs and everything at one corner, keep it in the half space, so that half space is empty. After that, you make a partition, you reduce the room size. You just don't directly reduce the size when there is a sofa lying in the other corner and the chair lying in the other corner, right? So it's always recommended to keep file system, the contents, whatever there inside your drive, to a location, reduce that first, and after that reduce the file system disk space. So now we have reduced the file system. Now let's try to reduce the disk size. So there is a command called parted. So let's do this. stc1 resize fsck stc and resize partition 1 200 MB. So it says that shrinking a partition can cause data loss, that I have already told in the beginning, that it's always good to take the backup. So it's again sending you the warning and asking, are you sure you want to continue with this? If you say let's do this, so it says you may need to update the etcfs tab, that is information it is giving it to us. So we have reduced the parted. Now let's do this. If you want to stc, you want to see the print, sudo /parted so it is printing that currently the size is 100 MB. It's a primary partition extended to file system. So we have successfully able to shrink the partition. Okay, sometimes you might end up getting the errors where the block sectors or hard block sectors, basically those are being corrupted. So in that case, you have to go to the recovery mode. There are a few commands that is being used to recover it, but considering this case, we did not come across such scenarios, so we'll be skipping that part. But in case if something happens while you multiple times try to shrink the partition, then chances that bad sectors can occur and corruption of the data can also occur. So you have to resolve that actually. So once you do that, after that you have to fix the file system and you can just mount it. So partition table mount -a. Let's type bad option, single parameters. You can have more information. So to extend, and once you do this, you can just check the file system. Verify. Okay, the file system size is this. Physical size of the drive is this much. Either the super block of partition likes to be correct. Okay, so this is again, it's asking me to. I'm aborting it for now, and you can just resize it. Resize to FS. C1. Okay. Resizing. So this is just to clean it. fsck-f. Okay, it has checked it. That is also good. And then let's try to run this mount command. Yeah, so now you see we are able to successfully mount the reduced file system, which was of 100 MB, and now we have reduced it, and after that we are able to mount it. So there are chances sometimes you come across with the errors like this, where you try to scan the partition, it's not able to do that. So we went, seems like we went for a moment in that stage, but after that when I rescan the partition, uh, it basically, after resizing it properly, it basically let me scan the partition, and then after that I was able to remount it. So shrinking is always risky, but yeah, you can do that. There are ways to do it. So these steps you can perform. About extend, it's easy because the extend is like you have to add one more extend the partition, and after that you can extend the file system. Once you do that, after that you can mount it. So it's kind of little easy. So let's try to extend it. Let's unmount it first. So we'll use it sudo unmount. Okay, let's verify the partition is unmounted. After that, let's scan it. E2 fsck after /dev/stc1. Okay, we are able to scan it. That's good. Now let's use this command parted. Sudo parted device resize part1 from 500 MB to, let's say, 300 MB. Earlier from 500 MB to 100 MB, and then now from 100 MB to 300 MB we are doing this. Okay, once that is done, you can resize the file system. Resize to fs command stc1. Okay, that is done. After that you can just print parted print command. Okay, now it is with the size 300 MB. Once that is done, you can scan the file system again. fsck-f stc1. Okay, and then you can just mount it again. Sudo mount -a. So now you see from 100 MB, now it is showing to 246 MB, and then that 300 MB has been increased, and now we are able to mount it and able to see the size. So you might see a slight difference in the size, whatever it is showing up here, because that's always be 1024 kind of a thing, right? So it's always be a less. That's how the partition and the file system are being used. So, but if you look at the overall, it's 300 MB. Earlier it was 100 MB, right? So that's how you can extend it. Now let's talk about the LVM partition. So before jumping to LVM, you should understand what LVM is basically. So it's kind of a logical volume manager. So LVMs are being used when you say, for example, that when you try to, so for LVM you have to create a physical volume, which is a PV. Okay, and then from that PV you can create a volume group, which is called VG, and after that volume group you have to create LV, which is called logical volume manager. So the partition is logical volume partitions. So that's the structure of creating a logical volume. Now you must be thinking, why should we use this LVM? So LVM is a way where mostly the partitions are being created. So there is another partition called RAID partition, which we will not be discussing in this. It also kind of used, and in the industry where they want to create a backup and stuff for the partitionings. But LVM is at least important, because you should know that in, let's say for example, in the same PV which is of 10 GB, for example, you can create volume group of 10 GB, and then you can create 1 GB 10 partition. So total number of 10 LVM partitions you can create out of that 10 GB. So 1 GB each. So that's how you can create more and more and more partitions. So when I was talking about maximum partition you can create in a hard drive is 4, and then we have, let's say, created 3 primary partition, and now the fourth one is extended partition. In that extended partition, you can create logical partitions, which are nothing but these LVMs. So there are commands. How do you achieve it? We will be talking about that and seeing in the demo. So let's see currently if we have any LVM partitions or stuff. So let's say first let's display if there is any physical volume present or not. So PV display will display you, okay, there is one physical volume which is present called device SDB2, and then it has a volume group as well, which is my underscore VG, that is also 5 GB. Okay, and then there is a physical extents which is 4 MB of size, and then total physical extents you can calculate based on the size divide by this, the total P you will get. How much physical extents are currently available? There are 904. So the commands that is required, so there is a software called LVM2 which is required for Ubuntu in order to create the LVM. So since I have already created LVM partitions, I don't require this package because it is already installed. Now let's check how to create a PV. So since I already created on device DB2, let me create in the new device SDC SDC, or do one thing, let's create another partition actually. Primary partition to first sector is fine. Let's create 2 GB if we are able to. Okay, W partition has been altered. Yes. Okay, STC2. Now NTFS 64. STC2. Okay, that is fine. Now let's try to create the volume PV create /dev /stc2. So ext4 signature detected. Wipe it. Yeah, let's wipe it. It's fine. So it has created the physical volume. So now if I say PV display, you would be seeing there are two PVs. This was the earlier PV, and this is a new physical volume that we have just now created of 2 GB size. So this displays the message like this because that is how Linux tries to update you that okay, this is a new one that you have created, this is the existing one which was already there. Okay, once you have created the physical volume, you have to create a volume group. So for that there is a command called VG create to create the volume group, and I want to give, let's say, StarAgile volume group to what drive STC2. Okay, volume grid group you can list VG display. This will display you earlier we were having my underscore VG, and now it has StarAgile underscore VG, which is a volume group, and the formatted and stuff, it is telling you all this information. Now once you have created this volume group, let's create LV. So to create LV, there is a command called LV create -L. So now we have 2 GB of space. So let's use this. Let's try to create 500 MB only, and -L for the name. Let's say StarAgile underscore LV. Okay, and from which VG, StarAgile VG. So this will basically create a logical volume partition of size 500 MB. The name of the logical volume is StarAgile underscore LV, and name of the volume group out of which this LV will be created is StarAgile underscore VG. So now let's see this LV display to display the logical volumes. So This was the logical volume which was previously created. Now this is the current logical volume that we have created on top of this volume group. Okay, so first create PV, physical volume, then volume group, and after that logical volume. Okay, so that is a 500 MB size. Now that's done. After that you have to format it again. So let's say MK4 ME2MS KFS64/dev. So the device name you will get it here. Okay, you don't have to remember this once you do this. So it has formatted our logical volume and then it is ready to use, and after that you can just mount it. So let's say I create a directory /mnt/ StarAgile_LV, and then let's see mount /dev/ inside /mnt StarAgile. So let's mount the partition that we have created, the logical volume. And if you look at here, we are successfully able to mount the logical volume partition on MNT StarAgile_LV is a file system. So let's conclude this session and let's recap it what we have discussed. So we have discussed that there are maximum of 4 partitions can be created in a hard drive. It's always a best recommended practice that you create 3 primary partition and the 1 extended partition. In that 1 extended partition, you always create logical volume partition so that you can have multiple partitions. Depending on the type of the hard drive and the supportability, maximum up to usually 60 partitions can be created in 1 extended partitions. So there are multiple options to format the drive. You can format it with NTFS, ext2, ext3, ext4, XFS, and GPT for high scale variety of partitions things. So while doing this shrinking operations, it's always recommendable to take a backup of your data because there are high chances to get the corruption for the data. So you should always take a backup before you do shrinking of the partition, which are not really needed in the industry real-time purpose. But yeah, in case if you had to do the shrinking part, you can definitely do it, but always take a backup. For extended the partition, it's nothing required, just extend the partition size or after that the file system size, and then you can extend the remount the partition. That will happen. It's good practice to label the partition so that the confusion should not get created, and it's always easy to find out the partition so that you can append in the etcfs tab file, so that while booting it up automatically the partition gets remounted. And then for the logical partitions, we discussed about it has to have the physical volume and then volume groups and the logical volumes, and the minimum unit for the logical volume is P, which is a physical extents. So number of P is depending on the size of the partition that you are going to create, so you can calculate that as well. So yeah, there are some other partitions as well, like RAID partitions and stuff. We will not go to that detail. So that's it for the partitioning and verifying the disk usage and file system usage here. If you want to learn Linux and get certified from IBM, click on this link given below in the description. That's a wrap for this chapter. I'll meet you in the next episode of this Linux series.